Hello everyone, this is Katna here. In this video, we are going to see a problem from mathematical induction. So let's get started. Problem: show that 1 by 2 into 5 plus 1 by 5 into 8 plus 1 by 8 into 11 plus so on plus 1 by 3n minus 1 into 3n plus 2 is equals to n by 2 into 3n plus 2. Solution: let P of n be the given statement. Then P of n such that 1 by 2 into 5 plus 1 by 5 into 8 plus 1 by 8 into 11 plus so on plus 1 by 3n minus 1 into 3n plus 2 equals to n by 2 into 3n plus 2. Okay, so here we are given 1, 2, 3 n plus so on n. Sum of n terms, right? Let's represent the first term by t1, second term by t2, third term by t3 and nth term by tn. Okay, so we have nth term 3n minus 1, 1 by 3n minus 1 into 3n plus 2. When n equals to 1, substitute n equals to 1. Is equals to 1 by 3 ones are 3, 3 minus 1, 2 into 3 ones are 3, 3 plus 2, 5. When n equals to 1, we'll get t1, right? If you put n equals to 2, we need to get t2, that is the second term. 1 by 3 2s are 6 minus 1 into 3 2s are 6 plus 2 equals to 1 by 6 minus 1 5 into 6 plus 2 8, which is our second term. Likewise, when n equals to 3, we'll get the third term. Okay, so now using mathematical induction, we are going to show that the statement is true. Okay, firstly, we'll show that the statement is true for n equals to 1, and we'll assume that p of k is true, that is p of n is true for some k, and we'll show that the statement is true for n equals to k plus 1. Firstly, we'll show that p of 1 is true. When n equals to 1, we'll take only the first term from LHS. 1 by 2 into 5 equals to 1 by 2 5s are 10. Now coming to RHS, put n equals to 1, you have n by 2 into 3n plus 2 as your RHS, right? So put n equals to 1 here. You'll get 1 by 2 into 3 times 1 plus 2 equals to 1 by 2 into 3 plus 2 equals to 1 by 2 into 3 plus 2 is 5. 1 by 2 into 5 is 10. So here LHS equals to RHS. Therefore, LHS equals to RHS. From this we can say that P of n is true for n equals to 1. Therefore, P of 1 is true. Likewise, we'll show for n equals to 2. If you want, you can check for n equals to 2 also. When n equals to 2, we'll take two terms. The first two terms from LHS, that is sum of first two terms from LHS. You're having 1 by 2 into 5 plus 1 by 5 into 8 equals to 1 by 2 5s are 10 plus 1 by 5 8s are 40. Now take the LCM of 10 and 40. 2 5s are 10, 2 2s are 4, 5. 2 10s are 20, 5 ones are 5. 5 twos are 10. Again. Okay. 2, 2, 2. 2 twos are 4. 4 twos are 8. 8 fives are 40. 40 is your LCM. So here you're having 10, right? 2 fives are 10. The numerator you'll get 4 plus 1 equals to 5 by 40. 5 ones are 5 eights are equals to 1 by 8. Now coming to RHS. Put n equals to 2. You get 2 by 2 into 3 times 2 plus 2 equals to 2 by 2. You can cancel this 2, right? Into 3 twos are 6 plus 2. 1 by 6 plus 2 is 8. So here LHS equals to RHS. Therefore LHS equals to RHS. From this we can say that the given statement is true for n equals to 2. Therefore LHS equals to RHS. From this we can say that P of n is true for n equals to 2. Therefore P of 2 is true. Likewise, you can show that the statement is true for n equals to 3, 4, 5 and so on. Okay, fine. Now I assume that P of n is true for n equals to k. Then P of k will be 1 by 2 into 5 plus 1 by 5 into 8 plus 1 by 8 into 11 plus so on plus 1 by 3k minus 1 into 3k plus 2 equals to k by 2 into 3k plus 2. Right? Sum of k terms equals to k by 2 into 3k plus 2. Okay? So now, since P of k is true, so now we are going to prove for k plus 1, right? So let's take LHS for k plus 1 terms. First term, second term, third term, plus so on, plus kth term, plus k and k plus 1th term. K plus 1th term is 3 times. Replace k by k plus 1. 3 times k plus 1 plus 2. Okay. Since we have the sum of k terms is equals to k by 2 times 3k plus 2. So we can replace this by k by 2 plus, k by 2 times 3k plus 2 plus k plus 1th term as it is. Okay, 1 by 3k, 3 into k, 3k plus 3 minus 1 into 3k plus 3 into 1, 3 plus 2. So this becomes k by 2 times 3k plus 2 plus 1 by 3k plus 2 into 3k plus 5. Okay. So now take the LCM of 2, 3k plus 2 and 3k plus 2, 3k plus 5, right? So we are going to take the LCM of 2, 3k plus 2 and 3k plus 5. 3k plus 2 and 3k plus 5. 2 ones are 3k plus 2 ones are 3k plus 5 ones. Okay, so LCM of these three is 2 into 3k plus 2 into 3k plus 5. So in the denominator of first term you have 2 into 3k plus 2. So in the numerator you'll get k times 3k plus 5. K times 3k plus 5 plus in the denominator of second term you have this 2, right? So you have to multiply 1 into 2. The numerator, done. Is equals to 3k square, 3 into k into k is 3k square plus 5 plus, 5 into k is 5k plus 2 into 1 2 by 2 into 3k plus 2 into 3k plus 5. So in the numerator you are having quadratic expression, right? 3k square plus 5k plus 2. So here you can split this 5k as 3k plus 2k. So you can write this as 3k square plus 3k plus 2k plus 2 equals to, now take 3k common from the first two terms. You will get 3k times k plus 1 plus take 2 common from the next two terms. You will get 2 times k plus 1. So you have k plus 1 common in both the terms, right? So take k plus 1 common from the two terms. You will get k plus 1 into 3k plus 2. Okay. So now you can replace the numerator by k plus 1 into 3k plus 2. So this equals to k plus 1 into 3k plus 2 by 2 times 3k plus 2 into 3k plus 5. So here 3k plus 2 gets cancelled, is equals to k plus 1 by 2 into 3k plus 5. The denominator you are having 3k plus 5, right? Since we need to write this in terms of k plus 1, consider 3k plus 5. Now we have to write this in terms of k plus 1, right? So take 3 times k plus 1, which is equals to 3k plus 3. Here you are having 5, right? To get 5, we need to add plus 2 to this 3. So that will get 3 plus 2, which is equals to 5. Now we can replace 3k plus 5 by 3 times k plus 1 plus 2. So this equals to k plus 1 by 2 times 3 into k plus 1 plus 2, which is our RHS for n equals to k plus 1. See, n by 2 times 3n plus 2 for n equals to k plus 1. So from this we can say that P of k plus 1 is true. Therefore, P of k plus 1 such that 1 by 2 into 5 plus 1 by 5 into 8 plus 1 by 8 into 11 plus so on plus 1 by 3n minus 1 into 3n plus 2. Kth term, right? So write in terms of k plus 1 by 3 times k plus 1 minus 1 into 3 times k plus 1 plus 2 equals to k plus 1 by 2 times 3 into k plus 1 plus 2 . Therefore, P of k plus 1 is true whenever P of k is true. Right? Thus, P of 1 is true and P of k plus 1 is true whenever P of k is true. Therefore, by the principle of mathematical induction, P of n is true. Therefore, 1 by 2 into 5 plus 1 by 5 into 8 plus so on plus 1 by 3n minus 1 into 3n plus 2 equals to n by 2 times 3n plus 2. So this completes the problem. So we have seen a problem from mathematical induction in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.